Good morning, students. I am Dr. Noor Danish, Assistant Professor of Department of Physics, Jamshedpur Cooperative College, Kolhan University, and I am going to deliver this lecture for the undergraduate student of semester 3 Physics Honors, and this lecture is for the entire university, but particularly for the cooperative college students. Okay. Now, I will be covering in this lecture the book or the syllabus of modern physics and elements of modern physics. Okay. And the first lecture will be on the photoelectric effect. Now, photoelectric effects, as it is coming from the name, it is one end it is photo, means light, and other side it is electric, it means it is electricity. Now, photoelectric effect was first observed by the Phys, okay, and he observed this using the zinc cathode and ultraviolet light. What is photoelectric effect? When a light falls on the material surface, it liberates or it can liberate free electrons, and these electrons will come out of the surface of the material. Now, in general, when the light is falling, sunlight is falling on the materials which are kept outside, it is not happening. But when we produce a suitable environment in the laboratory, it happens. Why it is happening in the laboratory? See, in order to liberate an electron from the surface of the material, you need to have electrolyte beams, okay, which have sufficient energy and having sufficient intensity to liberate. Another important thing is that you should be able to measure very small amount of current which will be flowing on due to the liberation of these free electrons. So that happens in this type of device where a cathode and an anode is kept inside a partially vacuum quartz tube. The quartz tube is used because it allows the passage of the bright radiation to fall on its electrode. When a potential difference is applied using a rheostat, a potential source and a key across the two electrodes, and the potential is varied in a way that we observe suddenly a small amount of current in the galvanometer. What actually this galvanometer deflection source? Galvanometer deflection source, that there is a production of current in that circuit. Now, where this electron is coming from? The idea is very clear. When the light is falling on the electrode, it is liberating the electrons, some of the electrons which were inside the electrode material, and these electrons are reaching to the opposite side electrode, and then that electrode which is connected to the opposite end, and then the battery and the rheostat, and this complete the circuit for the flow of electron. Now, if the light continues to fall, the process of rejection of electron will continue, and some of the electrons will be continuously getting liberated, and the galvanometer will be showing the continuous movement of electron from one side to another side. Now, as I said that a potential difference is to be applied across the electrode. Why this potential difference is required? Let's understand. There is a amount of energy which is required to liberate an electron from the interior of the metal to just above it, and when these electrons from just above get isolated and move toward the opposite electrode, they further needs energy. Means there is a two types of energy, which is one energy which is being used for the liberation of electron, and another is for the acceleration and the motion of the electron. So the energy required for the liberation of the electron is called stopping potential in terms of potential, and energy will be E into V0, where V0 will be the stopping potential, the potential which I applied through the potentiometer here. Now, if I look into my second figure, here I see I have given you on the x-axis applied potential difference, and the y-axis I am measuring the current. What I am seeing that the current, as I applied potential, a very small amount of current starts flowing, and that flow of the current is given by number 1. Now, if I am increasing, if I want to have more if I am increasing the potential difference, I am seeing that initially the number of electrons increases with the applied potential difference. However, that gets saturated after the certain amount. Okay. Similarly, if I am increasing the intensity to the more number of times, I will find that more number of electrons will be coming out of the material. However, their energy will be same. Okay, which can be understood. So, in concise, photoelectric effect is actually giving us the following factor. Number 1, it is dependent on the potential difference. Number 2, photocurrent is dependent on the intensity of the photons, which is primarily coming. Second, it is also dependent on the frequency of the photons. The fourth, it is also dependent on the materials which I am using as an electrode. And the last, it is all depends upon what will be the environment, because electrons can reach to this place only if it is fully or partially vacuum. So, as I explained, that increasing the potential difference, increasing the electrons, okay, initially, but then it gets saturated. So, as I explained, what is stopping potential? That was the amount of energy which was required to liberate the electron to the surface. The second thing is, I said about the intensity. What actually intensity means? Intensity means actually number of photons of large number of photons of same wavelength or same frequency. So, high intensity actually means more number of electrons coming to the surface, and if they have sufficient energy, then they will liberate more number of free electrons, and thus more number of photoelectrons will be produced. The third is effect of frequency. What will happen? What actually frequency is related with E is equal to h nu, means a photon will be higher in the energy depending on its frequency is high, and lower in energy if its frequency is low. Is it clear? So now E is equal to h nu. So if my photon has first sufficient energy, it will liberate electron. The second, if it has more energy, then it will give the further energy to the electron. Mean the the frequency of the photon is important in playing what will be the energy of my liberated electrons, and it should be always more than the stopping potential energy. The fourth factor is about the material. Which materials I shall use. So as I told you in the beginning of my lecture, the first material was zinc by the earth. However, this phenomena can be observed by most of the materials, and especially the first block elements of the periodic table: potassium, sodium, zinc, tungsten. All these shows this phenomena. Okay. Depend. Only the thing is, some of the material have lower cutoff potential, and some of the material have higher cutoff potential. Means the amount of energy required to liberate an electron will be higher in some cases and will be lower in some material. Why it is so? Because you can understand. Because some of the electrons which are in the K cell are also in the SEDF group. Okay, so lower electrons nearer to nuclear will be requiring high energy. Bigger items will be requiring less amount of energy to liberate electrons. So if you will see that stopping potential and the frequency is different, but one thing is very clear: all these shows linear behavior with the photon energy. Once the electron is started, then coming out of the material, the more the energy will be, the more the photon energy will be, the more will be the energy of the ejected electrons. So who explained it? Obviously, Einstein used his tremendous mathematical ability to explain and first hand to write in short what are the specific properties. So he postulated it in the five points. The rate of photoemission is directly proportional to the intensity of the incident radiation. Means rate of photoemission, the number of photons emitted per second, is directly proportional to the intensity of the incident radiation, which I explained. More will be the intensity, more will be the ejection. Number 2, the velocity and hence the kinetic energy of the emitted photoelectron is independent of intensity. So, as I said, the energy of the ejected photon is only dependent on the energy of the incident photon. It is not dependent on the intensity of the incident photons. Number 3, the kinetic energy of the emitted photoelectron is directly proportional to the frequency of the incident photon. It is clear to you. Number 4, the photoemission takes place only above a certain frequency. It actually means certain frequency means above certain energy. The photoemission will be taking place above a certain amount of energy. Last point, there is no time lag between the incident photon and the ejected electron. It is an instantaneous phenomena. If their energy is sufficient, the electron will come out immediately. If the energy is not sufficient, however, whatever be the intensity, no electron is going to come out of the surface. Actually, intensity means only numbers and energy means variation. Energy first for liberation and energy then for second for acceleration. So, Einstein explained it using the formula half mv square is equal to h nu minus h nu dash, where h nu dash is equal to the energy of the photons which will just liberate, and half mv square is the kinetic energy of the ejected electron, and h nu is the energy of the incident photons. Is it clear? Incident photon energy minus the just needed energy, will be equal to half mv square, energy of the ejected electron. Also, my half mv square will be equal to E V naught, where V naught is the stopping potential. So I hope you understand this lecture. Now I am giving you a problem to practice it, and the problem is very simple. You just write down the problem. Calculate the velocity of the photoelectron if the work function is the energy required for liberating the electron. If the work function of the photometal is 1.24 electron volt and the wavelength of the incident radiation is you need to convert it into frequency, is 4.37 into 10 power minus 7 meter. What retarding potential is necessary to stop the emission of these electrons? Once you will solve, you will understand the equation. This is only the basic one equation of the photoelectric effect. You don't have to have many equations. Now, why photoelectric effect was essential? Actually, photoelectric effect once developed, it constantly postulated that the light has dual nature, which is wave nature and the particle nature. This phenomena, that is photoelectric effect, is focusing on the particle nature of the photons. However, it also saying that ultraviolet rays means rays having energy and having energy in terms of quanta. Photon was having quanta, means having energy in the range of E is equal to h nu, and E is equal to n h nu, means photons, quanta of a photon can have energy in the range of 1 h nu, 2 h nu, 3 h nu as nh nu, where n was integer number. So thus photoelectric effect is actually the generation and the progress of the classical mechanics of classical concept of light toward the quantum concept. Okay, it is the beginning. The next we will be discussing Compton effect, which is actually the transition or the proving of that light got the nature. Okay, thank you. If you have any queries, contact me on my email ID noordanishahrar@gmail.com. You can also give this video will be uploaded on the YouTube, so you can also comment there or ask me question, and the lecture notes will be also delivered to you once you will be writing to me on my email. Thank you very much. God bless you.